Thank you. My name is Bertolt Niel. I'm part of Craftworkz. Craftworkz is, like Wim already introduced, we do prototyping. So we test technology with people. What we tend to see is that people do a lot of research with technology and using research companies. But research companies or those projects sometimes can take, 12, 48 months. So we tend to do it very quickly into what we say a month, 2 months of engagement with companies to test, in fact, those type of technologies onto their business. So with use cases that they do, with use cases that matter to the company itself. So today, virtual reality and the use case around virtual workplace and training. We've done this together with research from HOWEST. HOWEST has a research department which is very far in virtual reality and augmented reality cases, and we've done that research together with them. So the use case. So what do we do? In fact, we've looking at Industry 4.0 and looked at virtual reality and augmented reality and how does that technology fit in those business processes. And how do we do it? We tend to look at the discovery, where is the technology today, where it goes. We look at a project. So what we've done in this particular case, and I will show you later on, is that we've brought together, I think it was around 4 to 5 companies, and we searched for a common goal, a common research project that could reflect on every company itself. So we created a test project for those 4 companies. We demoed it. We tested it with 100 people at 4 companies to see how does that prototype work. We evaluate and we define next steps for the next iteration of that research. So these are the companies that we've looked into, TVH, Dana, Barco, Picanol, and CNH, and we've done it for either virtual reality and the other hand, augmented reality as well. So how does it look, virtual reality, and how does those work instructions come together? So first of all, there's a design of the piece that needs to be created. There's a test case, so we assemble in the real world. We do an assembly test to see how does it work. Then somebody will write work instructions, so piece A needs to go on piece B using a hammer or a screwdriver or whatever. And then we translated those work instructions into a virtual reality instruction. So in fact, what we've done is we looked at the work instructions which were physical on paper, and we tried to translate those into a virtual world. And then we used that to also, once we have the work instructions, we also have made a complete copy of the workplace, of the work environment in the factory itself. And I will show you later on how do we do that. But first of all, what was the result in the end is that we've created a common framework. A common framework which will allow, based on the cut content of the piece that needs to be assembled, to generate automatically the work instructions. There's work to be done there, but we try to automate as much as possible, that we don't need to write the work instructions twice, once physically on paper, once in the virtual reality. So we're now looking at either video recording to automate it, looking at what type of information can we extract from the CAD model to generate work instructions, how will we see when we need to use tools like hammers, screwdrivers, also machines that need to be involved as well. So we've done 2 real-life cases, one at Dana, where we, in fact, did a 3D scan of their factory. From a workplace in their factory, we've created a 3D scan, which you can see here. This resulted, in fact, in a Autodesk. I don't know if everybody's familiar with Autodesk. It's to model 3D pieces. This is what it looks like. This is another tool. But what you need to watch out for is when you do a 3D scan, I don't know if you can look closely enough, but it makes triangles to in fact create your virtual objects. What we need to do is, because there's a lot of triangles, and I will show you later on, we needed to get a good mix to be able to run it in a game engine, because virtual reality is based on gaming engines, and if the 3D content is too detailed and has too much the triangulations to create those, to draw in fact the 3D object in a virtual world, then you need to have enough hardware to support it, and today that's not the case. So we needed to have something, it's a process to minimize the triangles to create in fact the object in the gaming engine, and that it supports, because otherwise, yet again, the hardware does not cope with the amount of triangles that need to be drawn. So afterwards, so we go from a 3D program into a virtual gaming environment. This is what you see here. So you can see that's an exact copy from the point scan that we've created here. So this is in fact the result, and I will show you later on. In the real life demo, this is the environment. How does it look in a gaming engine? Next is in fact the 3D model. It's the same story. You need to look at how many polygons you will support in your gaming engine, and we've done some tests. This is to show you. You see on the left, you see many triangles to draw the same kind of object than you see on the right. This is yet again then how it looks in a gaming engine to in fact visualize the 3D CAD model into a gaming engine. We've done some tests on performance as well to look at frames per second. Frames per second is the amount. The lower the frames per second, the more not fluent movements you have. More frame per second means that you have fluent movements. So what we do is we had some questions from the companies to involve different kind of functionalities. For instance, you need to use tools, because when you assemble a piece, you will need to use tools to support that assembly. So we've incorporated tools, like you can see here, a hammer. We need to pick pieces from the different kind of boxes. We needed to integrate the work instructions. So today at Dana, people have a foil where all the work instructions are on paper, and we need to incorporate the same look and feel into the virtual environment, which you can see here. And you can see that it highlights the step that you're into. Yet again, with the same part number, you can see that once you highlight with your controller a part number, that the part number is highlighted, so you can check if it's the correct part number that I've hold in my hands in my controller. Next thing was that we needed the same orientation. So instead of just gluing two things together, it needs to be the same orientation, the same way that you do it in a real world. And this is, in fact, the result. It's a short movie, so you can look at the work instructions. You can pick objects. You need to put them in the right place. You need to take the next piece, look at the work instructions. Okay, it's the same part number. Put it in the right order, etc., etc. But I will give you a live demo at the end of my presentation so that you can see how it works. You need to also incorporate tools. Then our next case is Picanol. So we did a different approach to test, in fact, what works better, either a 3D scan or pictures. So this case for Picanol, we went to the factory, we took pictures of the workplace, and we modeled, in fact, the workplace. So you can see here left are the pictures that we've taken, and on the right, in fact, the result in the gaming engine. So you can see that it's in the exact copy. We've measured everything so that when people are in the virtual world, it's exact the same height of the tables, exact the same space between the tables, so that they learn the workplace in the virtual environment. This is some machines that we've modeled based on the pictures as well. And here we needed to operate machines. So during the process of the assembly, some of the operators need to operate machines, turn objects to pick up large objects, because we cannot simulate weight yet into virtual environments. So everything weighs the same thing, like nothing. So we needed to incorporate as well the machines that when people come into the real world, that they don't think that it's the same way, that you can just beam at something and that it comes to you. Some process to apply Loctite so that yet again, it's the same thing as a real world, the same kind of amount of handlings that you need to do. And then we had a question around the feeling of an object, the look and feel. So we could model this just in black. I don't know if the picture shows it very well, but this can be a black matte color. But what we've done is we incorporate the same amount of material, the same amount of lighting, so it looks exactly the same. Integration with different kind of machines, like I told you. For instance, for Picanol, they need to heat up a ring to put it over a pipe. So that's what we've done as well. Another question was, and that was a tricky one, is to fold pieces. You have pieces in cut which are static. But we need to incorporate, in fact, how to fold pieces when you use a tool, like in this case a hammer, to fold the piece in the right angle. And then we also needed to create a carousel of the picture. So at Picanol they have iPads with the work instructions on there, and we needed to incorporate the same amount of information from the iPad into the virtual world. Also a technique, so there's logic behind it, that they need to fasten or to tighten the bolts in a specific way. So we have logic around it that you use a particular way of tighten those bolts in a crosswise way. And yeah, yet again, they need to pick up bump boxes. So this is the result, same thing. You start off with a large object, you see the carousel of the work instructions there, you pick something up, machine, and then off you go. So we've done this, and we tested it at, I think, 4 companies. Yes, 4 companies, around 100 people. We did a test group of male and female, of people who worked at the company for 1 year, people who worked at the company for 25 years, to in fact get a feeling if this is something that they really would like to have in their day-to-day job, maybe for new guys coming into the environment, or for older people to use to get trained on a new assembly, on a new product that comes out. So the feedback was very positive. Here are pictures where we've done it at Dana, we've done it at CNH, we've done it at Picanol, and we've done it at Barco. Oh. And these are a little bit the quotes that came out. I left them in Dutch because they're quotes from people and I don't want to lose information in translation. So maybe I will go through them one by one. So it was very positive. Yet again, first thing is very good. It was to get to know the sequence of steps, and on the other hand, to know where everything is in the workplace. Some people find it maybe too difficult to learn for simple assemblies, but see the advantage into more complex. And the third one was good. So I don't know if you know the process, how they train people today, but they train people in the production environment. So there's the production assembly line which goes, and there's pressure, there's time pressure, and people don't tend to learn as fast because there's a lot of pressure because they need to cope up with the movement of the belts. So here they said, yeah, we can learn it in our own way, in our own environment, at our own time, with no pressure from external people who are pushing you to go faster and faster and faster. some two negative ones were, are you going to learn handlings? So in virtual reality today, we cannot simulate yet the amount of power that you need to put on to tighten a bolt. That's not possible today. Yet again, it's also not possible to simulate the weight of an object. Other people say, yeah, I don't think that virtual reality is something for us. We like to have a face-to-face training. Fine, I think that's true. I think that face-to-face training will never disappear. I think there will always be face-to-face training to help people, to guide people, but I think as a first step, virtual reality training can help them and speed up the process. Others say, yeah, faster to learn, and also something, quote which was very interesting to me, was that sometimes they hire people who do not know mechanics. Very interesting. So they probably will use the VR training as well during solicitation. So they will see if people have the feeling to assembly. Do they know how something works? Do they know what a hammer is? It's not maybe the question that you get when you are going for a job interview, but it's used as well to interview people to get, in fact, to see how the handling works. Are they familiar with what is a bolt, what is this, what is that? So that's really interesting. But just to show you now a real demo, I have a virtual environment coming up. Do you come and test it out? So people are in that environment. They need to pick up pieces and put them in the right manner. They need to take the next one. First, you need to operate the machine to put it in the right orientation. It's the other way around. Need to turn it again. Other way around. Yeah. Stop. Yeah. And then you need to take the hammer. Then first, yeah, and then the hammer. Yeah. So this is how it works and how you can see people operate in a virtual environment. Yeah. So this is the idea. So it goes on for 5 to 7 minutes, but it's just to give you an idea that you see that he needs to walk around. So the distance is the same thing as in a real environment. And he needs to do the same handlings as he would do to assemble something real. But you can also see that he can just beam at something and it comes to you. So we cannot simulate yet the weight in virtual environments. So that's something that we need to work on in the next phases. So that was my presentation. So.